All right. So before that, let me introduce myself. My name is Ganesh Ramaswamy. I'm a PhD scholar. I'm pursuing PhD in the Department of Applied Mechanics at IIT Madras. I'm working under the guidance of Professor K. Ramesh and under the co-guidance of Professor U. Saravanan from the Civil Engineering Department. So I welcome you all to this live session on problem solving, and I hope you will make the best out of it, and we'll both learn together the subject. Okay, so let us go to the first problem that we have here. A flat plate is glued on the roof and loaded as shown. Okay, so we have a flat plate here, and then at this point O, we have loads, three forces that are applied, and we have been asked some questions related to that. And also to note, we have been given the positive x and y directions. So x positive is this way and y positive is that way. So throughout this course, one point we should keep note of is that we will be using the right-handed coordinate system. X cross y is k, that x cross y is z, that will come out of the plane of the paper here. So this will be z, that is pointing towards out of the screen for you. That will be the sign convention used for the entire course, and that is generally the sign convention used throughout engineering mechanics generally. Okay, so we have three forces here: 40 Newton, 65 Newton and 50 Newton that are applied at these angles: 30, 45 plus 30, 75, and 40 from the x and positive x and negative x axis respectively. So they have said, let the resultant force applied on this plate at point O be represented by a force called F. This F is a vector. So we have to calculate the x, y and z components. So let us see how to go about that. So first we know we can resolve any force into its components, x and y components. Why we do that? It makes it easier to calculate the resultant forces by adding up only those quantities. Otherwise, if we go only by vector notation, it will be tough. Why it will be tough? Because each and every time we have to apply the cosine rule in order to calculate the resultant. So if there is a vector A and there is a vector B, let us say like this. If this were A, if this was B, how do we calculate the resultant? We know from the law of vector addition that the resultant R magnitude square is A squared plus B squared plus 2AB cos theta. Okay, if we were to decompose these forces into x and y, the Cartesian coordinate system, which are perpendicular, so what happens to cos 90? It goes to 0. So this entire term goes to 0. It makes our life simpler. This is why we are doing it essentially. Okay, so let us try to resolve this into its components and try to add up. Let f, the resultant vector, be represented by fx I cap plus fy j cap. In fact, if we have written I cap and j cap, we don't need the vector summation here, vector symbol here. Okay, so what would fx be? It will be for this 40 which is applied like this. This is our x component, this is our y component. We have to note that positive coordinate axis is given like this, y and x and y. So our y component for 40 is negative and x component is along the positive x direction, so it is positive. So we can write 40 cos 30 plus what will be the component in the x direction for the force load 65 Newton. It will be 65 cos 30 plus 45 plus, if we have to do add this component, we know that for the 50 Newton component, x component is along the minus x direction. It is not along the positive x direction. So either we have to substitute this with a minus here, or we should take the angle from here. Okay, what will this angle be? What will this angle be? If we see, this is the x and we have been given that this angle is 40. So naturally this is 140. So plus 50 cos 140. As an alternative to this, we could have also written minus 50 cos 40. It will come out to be the same. But we are following one convention, so let us keep it restrict ourselves to that. So what will this come out to be? 40 cos 30 plus 65 cos 75 plus 50 cos 140. This comes out to be 13.16 Newton. This is the x component. Similarly, we can calculate the y component also. What will that be? Mind you that y component for all these forces will be in the minus y direction. So we have to appropriately put negative for everything. So this will be minus 40 sin 30 minus 65 sin 30 plus 45 minus 50 sin 40 or 140, either way, because sine from 0 to pi, sine is always positive, so it doesn't matter. So what will Fy come out to be? Minus 40 sin 30 minus 65 sin 75 minus 50 sin 140. It comes out to be minus 114.92 Newton. And we have not, the question does not mention any other force that has been applied here, and these three forces are shown only in the plane. So naturally, what would be the z component? It is 0. So what did we get? 13.16. What have we got as the y component? Minus 114.92, and the z component is 0. So I hope this is clear. Okay, so let us write our force here once. It is 13.16 I minus 114.92 J plus 0K. This 0K we will generally omit, but just for the sake of completeness, I am writing this here. Okay. The next question that is asked is the position vector in meter of point A. Point A is over here. If you see, this is point A, with point O taken as the origin. So how do we represent a position vector? It is given by A something with respect to the other. So what this signifies is this is the position vector of point A with respect to point O. With respect to point O meaning we are fixing the origin at O. Okay, so what would this be? If we were to draw this diagram again, we can see this is 2 meters. This they have not specified. Let us take this to be H for now. And they have said this is point A, this is point O, and this angle they have mentioned as 25 degrees. Okay, so our position vector components are these. This is the vertical component, y component, and this is the x component. We are able to see that again for this position vector, x component will be along the minus direction, minus x direction. So we have to properly put the sign. So RA with respect to O would be, this is directly given. So this is minus 2 I cap. X is directly given. Y is not given, but we are given the angle. So can we calculate it? If we see for this triangle, tan 25 is 2 by H. 2 by H. So H is 2 cot 25 degrees. Okay, let me put this here. And the component is positive along the positive y direction. So it will be plus 2 cot 25 degrees J cap. K cap we don't need. K cap is anyway 0, but for the sake of completeness we can just write it. So what is this? If we calculate it, it will be minus 2 I cap plus 4 cot 25 is, sorry, 2 cot 25. It is 4.28, 4.29 j cap plus 0 k cap. So this is our position vector of point A with O kept as origin. Which is the option that is matching? Option D is matching, we can see. Okay. Now the next part of the question says, if the same load system is to be represented by a force in Newton and moment m, force F in Newton and moment m in Newton meter applied at point A, applied at this point, how will you represent the moment? So what is the concept under question here? The concept under question here is transferring a force from one point to the other and representing the entire force system as an equivalent force system. So we know if there are 2 points and we apply a force F, let us call this point A, let us call this point B. Now if we were to transfer this force, force is a sliding vector. What does that mean? That it can slide along that line without changing the external effects to the body. But we cannot simply displace it out of the line without without having to add something else. So if we were to place this force over here, we will have to put this force here, and then since initially there was no force here, we will also have to put a negative force there. So this force and this force, these two create a couple, which is the moment. So the point to remember here is, if we shift the force from one point to the other, that force has to be accompanied by a corresponding moment or a couple as well. So what will that couple be? What is the moment given by? It is given by R cross F. In this example which we saw, what is R? This is R. Okay. R of A with respect to B. The bottom index that comes here, that is the index B, that is the point about which you want to transfer the moment. Point A is the one where the force is actually applied. So that we need to keep in mind. Now according to this question, we have to transfer everything to A. So what will that moment be? R of O with respect to A cross F. F is the force, resultant force which we calculated, that was applied at O, that we already calculated. And this will be the position vector. Mind you, this bottom index is the place where moment is to be calculated. Yes, 1 minute, Sudhakar. We will just end this question and I will address the question that you have. Okay, moment is to be calculated. What is the top index where force is applied? So in our case, force is applied at O. Just now we calculated the position vector of A with respect to O, which comes out to be 2 I cap minus 2 I cap plus 4.29 J cap plus 0 K cap. Okay, so but in this question we want R of O with respect to A, because we are trying to put the entire system at A. So what will this be? We know it is minus of R of A with respect to O. So we just have to take the negative of this vector, which will be 2 I cap minus 4.29. One minute. This is slight problem here. Okay, we will take the doubts till then. What are the doubts? Sudhakar, somebody had raised a doubt, so you please bring up your doubts. I'll try to answer. Yes, yes, Sudhakar.
Uh,
Yeah,
so am I audible to you?
yes, yes.
So can you please explain once again about how you resolve those two forces into a moment, a couple, and a force? Can you please explain it once again?
Yeah, yeah, sure. 1 minute.
Yeah, thank you.
Yeah. See, basically, we have a force applied at one point. In order to shift that to another point, it has to be compensated because it has to have the same external effects. We cannot do it simply by changing the position because force is a sliding vector. It can only slide along its line of action. The If we have to shift it to some place else, so this has to be shifted like this. So we have to place another force that will negate, because at that point initially there is no force. So F is placed at A. If we have to place F at B, we have to put minus F also at B. This minus F and the F that was applied at A will create a couple. So we just
And
shift.
what about the
Yeah.
F which was placed at, I mean B,
Yeah.
which is pointing upwards?
Yeah, that is still there. So
Okay, okay,
when
so that is left out.
no, that is not left out. This is not left out. If you are able
Okay,
to see my this thing, this is not left out. Only this portion, the bottom force that was applied, that creates a couple. So if the point is that if there is a point where you have applied F, if you want to translate it to another point, that same force goes. In addition to that force, a couple also exists.
okay,
Okay.
okay, fine.
Yeah.
Thank you.
Yeah. Yeah. So any other questions that you have? Anybody? Any questions so far? No one. It is clear.
Sure,
Okay.
sure.
Yeah. Yes. Someone had unmuted. Please go ahead and ask your question. Okay. Actually, I'm having some problem with the pen I was writing with. So anyway, can you just calculate what this will come out to be? ROA. You can just take it down. What I'm saying. See, RA with respect to O is minus 2 I cap plus 4.29 J cap plus 0 K cap. Now, what will RO with respect to AB? It will be minus of this vector, which is minus of the entire RA with respect to O. That is, ROA will be minus 2 I cap minus 2 I cap plus 2 I cap minus 4.29 J cap minus 0 K cap. But plus and minus 0 hardly makes a difference. So that is what it will come out to. Okay. So anybody, can you just type in the answer that you have got? ROA is clear. Moment we have to calculate. R we have got. R is what? 2I minus 4.29 J. F we had calculated it here if you remember. What is F? 13.16 I cap minus 114.92 J cap plus 0 K cap. That is your force. So what will R cross F be? Do you people know how to take cross products? Generally we do that determinant I, j, k will be the first row. Second will be the components of R. What are the components of R? 2 minus 4.29, 0. Third is our component of force because we are doing R cross F. So third component will be 13.16 as we saw, minus 114.92, and third will be 0. So if you see under K both will be 0. Under I and J we will be having 4 entries. Can you just cross multiply and type in the answer that you have got? Because I would have done, there is some issue with the pen I am writing, so I need to fix that. In the meantime, can you just cross multiply? Anyway, I'll do it with my calculator. R is 2 into. Okay, so what is it that you have got? Anybody? Anyone can type in the answer? Okay, 560 minus 288. See why? If you see, because I'm not able to write with my pen, I'll just tell you what I'm saying. If you draw the determinant, you have I, J, K. Underneath I, what will be the first vector that we need to write? That is R. R of O with respect to A. What is that? 2 plus 2. Underneath J, it will be minus 4.29. And third entry will be 0. Next, we have to write the force. What will be the force? 13.16. Underneath J entry, it will be minus 114.92. Under the third entry, it will be 0. So if you take the determinant of this, only the k cap component will exist. Everything else will go to 0. You can cross multiply and see. Everything else will go to 0. Only the k cap component will exist. What is the k cap component? We have to cross multiply, right? What is the cross multiplication? 2 into minus 114.92 minus 4.29 into 13.16. What does that come out to be? Minus 173. Exactly. Kalpit Rathod got it right. So this will be minus 173 is our moment. Components of that were asked. So what will this answer be? X would be 0. X component of M is 0. Y component of M is 0. Z component is minus 173.38 K cap. So that is the answer to this question. Okay, so what we have essentially learned from this question, we have a point where force is applied. For many forces could be applied at that point. How we should resolve them first? Simplest way to resolve is resolve the components of each of the forces into x and y coordinate, x and y directions, and then add up corresponding x directions, corresponding y directions together. You will get the force at that point as a vector in terms of I cap and j cap. And if it's a 3-dimensional vector, you will get it as k cap also. Now we want to shift this force to some place else, not just shift. The constraint here is that it should be exactly having the same external effects. That is why we go for resolving the force into an equivalent force and a couple. So as you see on the screen, from point A, if I want to shift it to point B, as someone had also asked, first we will take this force at A. This is at A. Shift it to B. Again apply another negative force at B because initially at B there was no force. This negative force and the applied force creates a couple. This force already exists. So when the point to remember is when you shift from one point to the other, when you shift a force from one point to the other, there will be a force as well as an additional moment. If you do not account for that moment or couple as it is called, your answers will not come out to be correct. Okay, with this background, I'll just create one Google poll. On the right side of your screen, if you see, there'll be activities. There'll be a triangle, square and a circle. So I'll just create one Google poll. What do you think is the answer to this question based on the discussion that we have had? A, B. So I have just launched that poll. On the right side, you can see the activities. You can attend that poll. I hope you are able to see. So this is the question. For these four systems shown, see there are two bodies A and B. There are two load systems A and B. One where force is applied on the right side. That magnitude of that force is 10 kilonewton. And it is applied at a distance of 5 meter along the positive x direction from point O. Similarly, you have another load system where a moment is applied, where a couple is applied at O, and the magnitude of that couple is 50 kilonewton meter. The question is, are these two the same? Both load systems A and B are equivalent since the external effects are same. B. Both load systems A and B are not equivalent since the external effects are not same. C option is both load systems A and B are equivalent as long as this body where it is applied is rigid. D is cannot be concluded based on the data given. That is, you need to supply some more. The question is ill posed and you need to supply some more information to get the answer. What do you people think is the answer? Okay, I can see about 6-7 people have taken the votes. I would urge everybody to take the vote, take the poll. For poll, yeah, Rakesh, you have written B, that's fine. On the right side, you can see the activities. There you can actually take the poll. You can enter the answer there. Okay. C. B, A, C, okay. B. Okay. So on the count of 5, I'll close this poll. I've got some answers and then we'll take it from there. Okay, I'll end the poll now. Okay, so most of you have got the correct answer, which is B. The external effects are not the same. So load systems A and B are not equivalent. We cannot say that they are equivalent. For those who said that answer is A, and for those who said answer is C, okay, nobody has selected B, so that's fine. You are able to identify that there is no other thing that is missing from the question. You can conclude based on this. So those who have answered A and C, uh, I'll try to repeat it. See, the force on load system A, if you see it is applied, minus 10 is applied, but its magnitude is 10. Minus 10 is applied at a distance of 5 meter. So if you were to shift this force to O, you will get a couple of 50 kilonewton meter. In addition to that couple, the force also you have to transfer, right? So the force also would come at point O. So if you were to resolve system A, you will get a force at point O that is pointing downwards, that will be 10 kilonewton, and in addition to that you will get a couple that is 50 kilonewton meter. That couple alone is shown in the system B. So what would be the external effect of this force system A? Because of the force it will translate, it will go down. Because of the moment couple it will rotate. So it will be having a translation as well as a rotation simultaneously. Whereas if you see system B, system B will only rotate because there is no translational force that is causing its movement. There is only a couple that will make it rotate. So this is why these two are not equivalent, and hence The answer is B. So if you have any questions regarding this, you please unmute and ask. Any questions that are there, you can either unmute and ask, you can type in the chat box, I will try to answer it. Whatever is not clear, the idea here is not to get the correct answer always. The idea is to get your concepts clear. So I urge you to go ahead and ask any doubts that you have, so that you are thorough with transferring force from one point to the other. Why A not an answer? Explain again. Okay. Both load systems A. What does A say? That both these load systems are equivalent since the external effects are same. What are the external effects? When you have a body and you apply a force on it, it tends to translate along that direction, right? It will try to translate along that direction. If you apply a couple, it will try to rotate. If you see A, load system A, if you have to transfer this force A that is applied like this to point O, you will have this force and you will also have a couple. So what are the external effects of that system A? It will translate as well as rotate, because both the things are present there, force as well as a couple is present. In system B, there is only a couple present whose magnitude happens to be what the same as you will get in A, which is why you are saying that both are equivalent. But you have to account for the effect of that force also. This is why external effects are not the same for both these systems. Is it clear, Jiva? Jiva B? Okay. Any other questions that you have? Anything else? Nothing. Okay. Anyone else that has any questions apart from Jiva at this juncture? Because I had planned to solve the question, one more question, but unfortunately the pen that I'm using the has some problem. So I won't be able to go ahead solving the problem now. But I will fix this and we can take it up in the next session that we have. We will be having the session every Friday. So on Friday, I will go a little longer. I will solve the questions that I wanted to solve here. And then I will also be solving questions from week 2, that is under the topic of discussion of the next week. So we will have a longer session on Friday. Before that, if there is any question, I'll be happy to answer it. Sir, in question 1, can you please explain RO and RAO vector? Okay. Let me start from the question itself. Okay. You have a point A, you have a point O. Now, when we say position vector, it is always with respect to some origin. Now, if we say RA/O, it means that we have fixed the origin at O and we are looking at A. What will be the position of A with respect to how we see it? V meaning the origin sitting at O. That is RA with respect to O. Whereas if we were to sit at A and look back at R, it will just be the negative of that vector, right? So that is what it is. Devta, is it clear or you just? Yes. Okay. Yeah, Sudhakar Maladi, you had some question. You please unmute and ask. No problem.
So, I
Yeah.
mean,
Yeah.
whatever the technique that we are trying to implement here,
Yes.
is it only for concurrent forces, or I mean, suppose if we have non-concurrent forces,
Okay.
so when we are trying to make them into concurrent forces,
Yeah.
so we have to shift that force and apply
Yes.
a moment. Is
Yes.
that the movement?
Yes. Exactly. Exactly. So here this so happened that at O, all the forces were applied which were concurrent. So if you have to
Yeah.
even shift R cross A, R is 0. So 0 vector cross anything is 0. So there is no moment. Whereas if you had to split this, if this 40 Newton I had to apply somewhere else, but I had to calculate it at O. then there will be an additional couple because of R, because of the existence of R. You can just consider that in a concurrent force system, R which has to exist is 0. So you don't get any moment contribution is 0. Yeah.
I mean, if I have to show that fixed flat plate, whatever is fixed to the roof,
Yeah.
as a free body,
Yeah.
then how do I calculate the reaction on the surface? I mean, if I want to do that.
Okay, reaction on the surface. Along the surface, if you see, you have to take a moment, right? Basically, you have a reaction on the top which will be distributed as some kind of pressure.
Yes. Okay. I
Okay.
mean, if we consider it a force.
Yeah. Yeah. If we consider it a force, that force can again move at any point, no? So what we the question, the third question that we asked, that if this were to be represented by an equivalent force and moment at A, let us say A is at the surface, okay, and we are drawing the free body. Now we have to transfer all this to A. We will have one force which will have to balance this out, balance out the downward motion. If we see here, Fy is minus 114.92. So this the force applied at O, the plate is being pulled down by 114.92. But we can actually see that it doesn't move. So the top surface, the roof has to apply equal 114.92 to counter this force. But this we have only balanced Y. We have to balance X also. Then we have to adjust for the rotation also, because we can see that this is not rotating. So this will come under the topic of equilibrium, which we will be dealing with in the next coming week only, in week 2. But I'm just giving you a brief idea about how it is to be done. We will deal with it in more detail on coming Friday.
Thank you, sir.
Okay, yeah. Is my delivery okay? You people find it hard to follow or anything like that, or am I clear? Should
sir,
I?
it is clear.
It's clear. Okay, that's fine. Thank you. Okay. Any other doubts anybody has? I can see that some 26 people have joined. So, if there are any other questions in general relating to the subject, you can just ask. Because as I mentioned, there is some technical problem because of which I am unable to solve. I'll just give you a brief of what was the question I was trying to solve. After this, this was the question I was trying to solve. I was planning to solve. So you can just take a screenshot or something. You just take a snip of that question, and I would appreciate if you also give it a go by next week. I will anyway be solving this question next week, starting Friday at 6 o'clock. I will first solve this question. Then we will move on to the questions that come in week 2, that is to do with equilibrium. So next week session will be a bit longer. I request you all to bear with me, but I hope that if you solve along with me and ask the doubts that get, because most of the times what happens is, it's not that we don't know the entire concept. There'll be some small gap that gets left out, because of which you are unable to solve the problem. So this session only serves to address those small gaps. If there is something not clear, instantly you get an answer, you also feel satisfied that you're able to solve the question and move forward with it. So I hope you make the best out of this initiative, and ask your questions so that I can answer them. So I hope you have taken a screenshot of this question. This is what I will be solving first in the next session. Any clues or something that you want on this question, how to proceed with it? Let us look at the first question. Length of the position vector of R with respect to with respect to point A. So just now I explained how to get the position vector. Option A. Okay. Pavan has said it is option A. That's good. So how to solve this? Does anybody have 10.19? All right. So does anybody have any doubts as to how this is solved? Answer is 10.19 only. Answer is A. How this is to be solved properly, that I will show in the next class. But do you have any questions about how to approach this? If you have, please unmute and ask. I'm happy to answer this. See, if we see here, the bottom of the flag post, we can see that X, Y, and Z are emanating from the bottom of the flag post. So the bottom of the flag post is actually the origin of the coordinate system. So we have 2 points, both are not the origin. The origin is at the bottom of the flag post. How will you calculate the position vector of one point with respect to the other point? So basically what we are trying to calculate here is RB with respect to A, which is nothing but RB with respect to O minus RA with respect to O. That is how it is to be done. And I can see that some of you have already got the correct answer. So in case you didn't get it, you just give it a go, and in the next class we will be solving this. Yeah, Sudhakar.
So, I mean, in this situation, we can, since they did not mention that the origin is at the base of the flag post, we can also consider it at A, right? I mean, there
Yeah,
is nothing wrong.
there is nothing wrong. You can consider it at A. But one thing that you said is they have not mentioned origin at origin is at O. But if you see X, Y, and Z, where do they intersect? That
Okay, I
intersect,
mean,
yeah,
the
yeah,
reference frame can be shifted, right?
shifted. Absolutely, it can be shifted. There is absolutely no problem. Only thing is people sometimes find it tough to sit at a point in space and then look around. So that is why I said that you can take bottom of the bottom of the flag post to be the reference. There is absolutely nothing. It is just a, you have cut down one step. You are directly placing the origin at O and looking at point B. That is absolutely fine.
Yeah. Okay.
Yeah. And in addition to this, as I already mentioned, I would urge you all to go to the Swayam portal today. See, there is an option called Ask a Question. If you click on it, it will take you to a Google forum. It will take you to a Google forum. You can join that forum and you can also raise your questions there. It will be answered there. And if you have, suppose if you don't have a question and someone else has, you will also be getting the response to that. So that if there is any gap that gets left out, it will get compensated. So now that some of you have solved the first part, can you just give the second part a go in a similar vein? Point C with respect to A. It is just we are transpositioning the point. That's all. So anyone has an answer to this? Okay, not the magnitude. Don't give me the length. Just give me the x, y, and z components. You can just separate them out with a comma or something and just type in the chat box. Option B. Okay. Pavan, you have written option B. What are the x, y, and z components that you have got? Because you see, magnitude generally it is squaring of a negative quantity. So it is possible that there could be 4 to 8 vectors that could have the same this thing, same magnitude, but needn't be the same vector. Yeah, can anyone give me the components of this vector? 3, 2, minus 8. Yes, exactly. So that's good. Anyway, these things are clear. Okay, in general, what is it that you find the hardest to understand in engineering mechanics? To start with, if you have looked at week 1, what is the thing that you are finding it hard to grasp? Is there any such aspect, or it is just smooth? I'm sure you would have seen 4 lectures by now. 2 are in introduction where the professor talks about how history of the subject and other aspects to it. And third and fourth lecture are basically they start with the force systems. So is there any aspect that you are at this juncture, I'm saying, just from these 4 lectures that you are finding hard about understanding or something like that? Okay, so I think it is clear so far, because this is anyway very fundamental in nature. Because we have been dealing with vectors and forces from class 12th, class 11th in fact. So it goes comfortably generally. As we step into new topics like after equilibrium is also somewhat understood. As we move into trusses, that is where you actually get a lot of doubts, because there is moment of section, uh, there is a method of section, there is a method of joints, and then what is determinate, indeterminate, what are the arrangements. There are so many questions that come in. So we will hopefully go through all that together. And if you have any other people in your circle who are interested in joining this session, you're more than welcome to share the Google link, and they can join the session coming Friday. So throughout this semester, every Friday 6 to 7 we will be having the problem solving session. 6 it will start, it needn't end at 7. That is what I'm trying to say. If you have doubts, we will go about, we can extend it a little more also, not a problem. Yeah, Sudhakar.
So actually, the timing is colliding with other NPTEL courses.
Okay.
Same. Yeah. So can we resolve it? I mean, is there any other way to go around it?
Actually, you see, this timing has been set by the NPTEL team only, and if you look at their curricula, it is having about 450 courses, pan India courses that are running. So naturally, a clash is unavoidable. In such a case, what I would suggest you do is see these lectures, these not lectures, these sessions that we are having, these also will be recorded. I'm recording it, and we will be posting that also onto the SWAYAM portal, or how it is that the modus operandi they will be deciding. But you will be getting a copy of this live session also. And in case you watch the live session later and you have any doubts, you are more than welcome to ask it in the forum. We will answer it as soon as possible. So
Okay.
there are multiple ways for you to approach us and get your doubts clarified. At least for engineering mechanics, let me assure you that if you have any questions in the forum, you are free to ask. Forum, we have been answering the forum for the past 2 years. So that has also many people get their doubts clarified there. That is another way for you to approach us to get your
Yeah.
doubts resolved. Okay. Yeah. Anything else? Anybody else? Any other questions? Questions, concerns, something, anything? So I'm given to understand that you people are have enrolled into Swayam through your college course, is it? College first year course. I mean, I understand. Like people like Ani Chandran had mentioned that he's working, and just out of interest he has joined, which I appreciate very much. The other people, I'm told that they are from some college, different colleges, and you people have joined. Can you just type in yes if that is so? How many people? I just want to get an idea about. You can just type yes in the chat box if you are joining this through college course. I'm working. Okay. Yes. Okay. Okay. All right. I'm from Civilpur. Oh, that's nice. Okay. Okay. Yes. Okay. All right. Okay. That's good. So, I mean, not only there is an additional push when you are in the college, there is an additional push for you to do the course. So, I hope more people will join in the coming sessions, and we will discuss much more. So as of now, I think I have nothing more to say. Just that this question I will be taking up next week, as I had mentioned, along with the questions of equilibrium. So I suppose if there are no further questions, then we can consider ending this session now, and look forward to seeing you next week, Friday at 6 o'clock. Thank you.